Welcome back everyone to our YouTube channel. This is Namakando Academy. With us we'll be looking at physics, a problem under dimensional analysis. So this problem presented before us is divided into two parts. The first one, as we can see, is about stating the principle of homogeneity. That's the first problem. The second one is to test the dimensional homogeneity of the two equations presented here, which are A, S is equal to ut plus half at squared, then B, S subscript of n equal to u plus a over 2 in brackets 2n minus 1. Alright, so let's get started. So the first part is principle of homogeneity. That's our first part. So the first part is us stating what this principle states. So the principle of homogeneity states that for an equation dimensionally correct or homogeneous, the dimensions of both sides of the equation should be the same. So the two sides of the equation should be the same. That is dimensionally. So if this holds, it then means that our equation is dimensionally homogeneous, or rather dimensionally correct. So this is what the principle of homogeneity states when it comes to the dimensions of a physical quantity. So whatever you have on the left in terms of dimensions should be the same as what is on the right. Okay, so this is the first part of the problem and it has been answered successfully. We now progress to the second part. So the second part has two parts, which are A and B. Now part A is where we've been given an equation S equal to ut plus half at squared. So want to test the homogeneity of this equation. Now from the statement we've just given, we've said that for an equation to be correct, or rather dimensionally homogeneous, left hand side should be the same as right hand side. So I mean that what we're going to get for this equation dimensionally should be the same both sides of the equation. So let's provide the dimensions of each side. So let's start with left hand side. Now in order for us to be able to identify the dimensions, it is very important that we know the physical quantity we're dealing with. Now S is simply a symbol used to denote the displacement of an object. Now displacement as we know it is simply the overall change in position, of which in this case we're simply talking about length between the 2 points in which the particle is going to change. So here what we're looking at on the left hand side is displacement, which is length, and length has dimensions of L like this. So the dimensions of our left hand side is L, thus we should get the same as what is on the right, and if this holds, then our equation is dimensionally homogeneous. Right hand side. So on the right hand side our equation is ut plus. Now we need to note that when it comes to dimension analysis, we only consider the dimensions of physical quantities. Thus constants are considered to be dimensionless. They don't have dimensions. And if you encounter a constant in your arithmetic, it is very important that it is phased out, or rather ignored. So in this case, since half being a constant has no dimensions, we are going to ignore it in our arithmetic. So this will just be presented as ut plus a t squared. So looking at this part, there's u, which stands for initial velocity, but since dimension analysis doesn't provide the magnitude, initial, final velocities are all regarded as the same when it comes to the nature. So thus here we only consider the dimensions but not really the magnitude. So initial velocity, final velocity, or any just other velocity, they are all the same when it comes to dimension analysis. Then t is simply time. A is acceleration, then t squared is just time, which is being multiplied by itself twice. So let's provide the dimensions. U is velocity, and its dimensions are L, t, the power negative 1. So we represent this using square brackets like that. Then we multiply with t, which is time, and this dimension is a capital T. So also indicate brackets like that. Then from there we add with A. A is acceleration, and by now I believe we all know the dimensions, like how to come up with the dimensions of physical quantities. So for A, the dimensions are L, t to the power negative 2. Then we indicate brackets like this. Then we multiply with t is time, and since it is squared, we're also going to square our dimension like that. So this is what we have on the right hand side. Now what we are left with is to simplify. So we see that this part and this one are multiplying. From this first bracket, we have a t and also have it here. Since they are multiplying, we simply add the bases. Since we add the power, so this gives us L, t, negative 1 plus 1, like this. Then we say plus. Then we have L, t to the power negative 2 multiplied with t to the power 2, so add the powers. So it becomes negative 2 plus 2, like this. So simplifying this further gives us square brackets L, t to the power negative 1 plus 1 is a 0, like this, plus L, t, negative 2 plus 2 is also a 0. So this is what we have. Now we understand, say from mathematics, given a base which is not 0 and it is raised to the power of 0, it gives us a 1. So this will be L, like this, plus here also get L. Now when we add these two together, algebraically we get 2L, like this. And like what we've stated, constants are to be ignored. Thus this is just L, like this. So since left hand side, so we therefore conclude, say, since left hand side is equals to right hand side, our equation is dimensionally homogeneous. Okay, so this is our first part, or rather this is part A of our second problem. We now move on to the second one. So the second one is u plus a over 2 2n minus 1, like this. Just confirm. Okay, that's how it is. So this is our equation. Now let's look at left hand side. This is just displacement we have, and we have its dimensions to be L. Okay, moving on to the right hand side, we have u plus, this is half, we can write it like that. Multiplication being commutative, we can bring 2n minus 1 first, then we conclude with a, like this. So we've just used the property of multiplication, which is really not. So right hand side is u plus, so there the second part is where we've simply used the property of multiplication, of just change the order of the values. So we've started with numbers first, being that n here is just some integer. So we have half to multiply with 2n minus 1, then multiply by a at the end, which is a physical quantity. Now, the ones which are constants are going to be phased out. So just get it like this. Now, u is initial velocity, which is L t to the power negative 1, plus a is L t to the power negative 2. Now, if you look at these two, they are not like terms algebraically. Thus, we can't go further. So this therefore means that for right hand side, this is where we end. Now the thing is that if we do a comparison between left and right, they are not the same. So we therefore conclude to say, since left hand side is not the same as right hand side, the equation is dimensionally incorrect. Thank you for watching this video.